Hi guys, this is Mrs. Gastler, and in this video we're going to talk about Newton's third law, and we're going to draw some force diagrams to help us think about what's going on. And so let's get started. All right, let me flip to this thing, which doesn't need to be there. Okay, so let's start with what it says. Newton's third law says that for every action force, there is an equal and opposite reaction force, equal in magnitude and opposite in direction. And you might notice that you've heard this in the past, but maybe it didn't have this word here for, whoops, that's a little big. Let me fix that real fast. Here we go. You might not have seen the word force in there, but I found that when people try to apply Newton's third law, they often leave the force out, and then they use it wrong. Okay, Mythbusters, they use it wrong all the time because they forget that it's about forces. Okay, this is about forces. Okay, so when we say magnitude, we're talking about the size of the force. You might remember that we talked about in Unit 4 and in Unit 5. Magnitude tells us about how big the force is. If you did the first activity, you saw that whenever one thing was 4 newtons, the other one was probably really close to 4 newtons. That's the size of the force, but they are in opposite directions, which means they go in different ways. Which way is what we're talking about with the direction. Okay. So when we're talking about the action force and the reaction force, there's some points that we want to remember about those, okay? And so the action force is always equal. You'll notice that it doesn't say unless or except or only when or something like that. It doesn't matter if one's moving, one's not moving, one's bigger, one's smaller. The forces are always equal. It just says they're equal and opposite, period, okay? And they're always opposite. They're always in opposite directions. If one is right, one is left. Sometimes it might seem like they're both in the same direction, but that's actually not the case. They're always in opposite directions. Later, when we're identifying action and reaction force pairs, you will want to remember that they're always in opposite directions. And if you pick two that are in the same direction, they're probably not a pair, okay? They always happen at the same time. Sometimes students are like, well, you know, if I hit my brother, he's going to hit me back. Or if I do this thing, that person's going to do this back. And, you know, that might be true, but that's not the reaction force that we're talking about. That's what happens next, okay? That's something else. But if you think about it, the reason people get injured in like a boxing match or a fist fight is because when you use your hand to hit something, your hand feels a force also, and that can injure your hand, and that's why some people get injured. That's why you have to be really careful when you're hitting things, because you can get hurt too. And then the last thing is that those forces are always on different objects. So if you end up with an action and a reaction force pair, but they're acting on the same object, you're probably not talking about an action and reaction pair. You might have two forces that are in opposite directions, but if they're acting on the same object, then they're not an action and reaction pair. They're just forces that happen to be in opposite directions. That happens a lot. Like the normal force and gravity, they are in opposite directions, but they're on the same object, so they're not actually an action and reaction pair. They're just two forces that are in opposite directions.